Hello, so in today's lesson, our learning target is I know and can identify the 8 properties of equality. Um, so over the next few days, we're going to jump into solving single variable equations. And in this lesson, we're kind of just going to go over the tools that we can use to solve those equations and how to identify them. And this is really important because even though some of these properties we take for granted and probably seem pretty obvious, it's really useful for us to be able to explain our problem-solving methods either on our work, like on our homework, tests, or quizzes, or so that you can explain it to others and prove to people that you know what you're doing. So the first property of equality, which is very obvious and I'm sure we take for granted, is the reflexive property. And what that tells us is that for some number A is equal to itself. So an example of this would be like 1 is equal to 1, 16 is equal to 16, or x is equal to x. So this property, it looks really obvious, and that it is, but it's really important because if we couldn't say 1 is equal to 1 and 16 is equal to 16, pretty much every other mathematical rule would just fall apart right there. So it's really important that we have this in writing. So next is another one that you probably take for granted, is the symmetric property. The symmetric property tells us that if A is equal to B, then B is equal to A. So essentially, we can flip the sides of an equal sign and it's still the same. So this would be like if 5 is equal to x, then x is equal to 5, would be an example of that. So we'd have if 2x minus 14 is equal to 75, then 75 is equal to 2x minus 14, and so on. So that is our symmetric property. Now we're going to jump into looking at ones that are slightly less obvious. We have the transitive property. So the transitive property tells us that if A is equal to B and B is equal to C, then A is also equal to C. So if A is equal to B and B is equal to C, then A is equal to C. So an example of this would be like we have 5 is equal to y, and y is equal to 2z, then 5 is also equal to 2z. So again, we're just applying 5 is equal to y. Then we also know that y is equal to 2z, so that means that 5 has to be equal to 2z. Another example would be 2x minus 1 is equal to 7b, and 7b is equal to c, then 2x minus 1 is also equal to c. So that is our transitive property. We also have the substitution property. Our substitution property tells us that if A is equal to B, then B can be substituted for A in any situation. So an example of this would be like if x is equal to 19 and 2x minus 3 is equal to y, then 2 times 19 minus 3 is equal to y. So essentially the substitution property is kind of similar to the transitive property. It's telling us if we know that a is equal to b, so in this case x is equal to 19, whenever we see x, we can just plug in a 19 in place of that x. So we actually use this when we evaluate expressions for a given input. And substitution, we're going to be using this the whole year. That's going to be something that doesn't go away. I'll just do one more example. So we'd have like, if a is equal to 6, then negative 5 times a be equal to negative 5 times 6, which is equal to 30. So that is the substitution property. So now, those are our first 4 properties. We have 4 more to go through, most of which should be pretty quick. So I'm going to get a new whiteboard. So first up is the addition property. The addition property tells us that if a is equal to b, then a plus c is equal to b plus c. This is essentially telling us if we have an equation and we add the same thing to both sides, it's still equal. So that would be like, if x is equal to 5, then x plus 2 is equal to 5 plus 2. So we can add the same thing to both sides of an equation, and it's still equal. So we use that a lot when we're solving equations. Similarly, we have the subtraction property. Subtraction property is very similar. It tells us that if a is equal to b, then a minus c is equal to b minus c. So we can subtract the same thing from both sides of an equation without any worries. So if y is equal to 19, then y minus 5 is equal to 19 minus 5. That's an example of how those properties could be applied. And either of these in like a real situation where we want to solve an equation, if we have like if we have like x plus 8 is equal to 14, in order to find x, we would apply the subtraction property by subtracting 8 from both sides. We would get x is equal to 6. So again, these are properties that are very useful to us that we're going to be using all the time, and you probably already have used a lot. So now we have our multiplication property, which tells us that if a is equal to b, then a times c is equal to b times c. So this tells us essentially if we have an equation, we can multiply both sides by the same number, and it's still an equation. So if b is equal to 6, then 2 times b is equal to 2 times 6. That's an example, and how we use this in a real equation is if we have 1/2 x is equal to negative 4, we might choose to solve this equation by multiplying both sides by 2. These two will cancel out. We get x is equal to negative 8 as our answer. We just have one more, which is our division property, which tells us that if a is equal to b, then a divided by c is equal to b divided by c for c not equal to 0. That's just because we cannot divide by 0. You're not allowed to do it. So an example of this would be like if x is equal to 10, then x divided by 5 is equal to 10 divided by 5. And we'd use the division property in a case where we have 3x is equal to 18. In order to solve this equation, we would want to divide both sides by 3. We would get x is equal to 6. So that covers all of our 8 properties of equality. They're again very useful because they'll just help us to better explain our work and what we're doing. In our next lesson, we're going to use these properties of equality and apply them to solving single variable linear equations. So stay tuned for that.